So let's discuss today's lead code problem, count vowel string in ranges. So if you know how the prefix array works, this question would be a cakewalk for you because it is purely based on prefix array or how we can find the prefix count. Okay, so you are given the array of string. So you are given a zero-based array of string words and a 2D array of integers. So two arrays are given to us. One is the 1D array of strings that is basically represented here, words, words array having only string values, and a 2D array of integers having queries. Okay, 2D array of integers having query. So this is the 2D array only having two integers and its name is query. For each query element, we have li and ri. Ask us to find the number of strings present in the range li to ri, both inclusive of words that start and end with a vowel. So let's break it down. For the queries array, a single 1D array represents li or ri, or what we can say the lower index or uh, the left index and the right index, both inclusive in a manner कि the word starting from index 0 and ending at index 2, we need to find the count of strings that are that starts with a vowel and ends with a vowel. Okay, so based upon the query that is present, let's suppose for example 0 comma 2 is present from the index 0 to 2 because inclusive is given to us. From index 0 to 2 we need to find the strings that starts with a vowel, that is a e i o u, and ends with a vowel. So from for this particular query, zero index starts with a A and ends with a A. Yeah, it is satisfying the condition. For BCB, it is not starting with the vowel, so we will not take it into count. We move to the next string. It starts with E and ends with E. Yeah, it starts with a vowel and ends with a vowel. So we can say for the query 0 comma 2, that basically computes for the strings that ranges between 0 to 2. We are having only two strings that starts with a vowel and ends with a vowel. Okay, the question is really simple. So if we try to do it in a brute force way, what we can do, ABA, let's copy the test case first, BCB, ECE, AA, and E. These are string, that is words, and the uh, queries are 0 comma 2, 1 comma 4, and 1 comma 1. Okay, so 0 comma 2, what we will do in the brute force approach, because we just need to find the number of strings lying between the particular ranges. So we'll start our traversal from this particular index in the words array. Okay, we start our traversal from this index 0 and ends our traversal at this index 2. We traverse for this particular query and try to find if this particular string is starting with a vowel and ending with a vowel. Yeah, it is starting with a vowel and ending with a vowel. We increase our count to count by 1. I move to the next string in the range. BCB. It is not starting with a vowel. Okay, move to the next. ECE. It is starting with a vowel and ending also with a vowel. We increment our count by 1. Then it will give us the output as 2. Yeah, it is 2. Similarly, for the range 1 comma 4, 1 comma 4, we'll traverse this particular range. For BCB, it is not applicable because it is not starting with vowel and ending with vowel. It is applicable because it is starting with the vowel and ending with the vowel. So our count will be increased by 1. Then we move to the next A comma A. Yeah, it is also starting and ending with the vowel. The count will increase by 1. For the next Yeah, it is also starting and ending with a vowel. Our count will be increased by 3. So for 1 comma 4, we would be having our output as 3. It is 3? Yeah, it is 3. For 1 comma 1, now for the next range, we have 1 comma 1 starts at 1 and ends at 1. So just the index present at the 1th index. So it is not starting with a vowel. So we just have 0. So this is the brute force approach in which for every query, let's suppose its size is n and its size is m. For every query, what we need to do, we need to traverse for every element and try to traverse the words array. So in the worst case, what can be possible? The worst case, it is n into m time complexity. In the worst case, in which we need to traverse from 0 to 4 or 0 to 3. In that particular test case, we need to traverse for each and every, what we can say, element of queries and traverse the mth elements of the words. So yeah, and we will not be requiring any space complexity because we are just ranging over the indexes present in the queries. Okay, now the optimized approach of this can be, what we can do for every element. Let's suppose I'll write here words equals to ABA, BCB, ECE, AA, and E. Okay, we know for sure if we calculate if this particular string is starting with a vowel and ending with a vowel, and if we pre-compute it, we can ease our computation. We don't need to compute for every particular range. So what I'm thinking, I'll pre-compute it. Pre-compute the pre-compute if the string is starting with vowel and ending with vowel. Okay, I can pre-compute it, and after pre-computed it, what we can do, because we are basically working on the ranges, and when we are working on a ranges, we will surely be maintaining a prefix, a pre-computed array, or we can say कि we are maintaining a prefix array, कि we will be pre-computing for this particular range the number of elements from the starting would be this. uh okay, I would first maintain a prefix array, and I'll explain what I'll be doing. So firstly, I'll create a prefix array of the size that of the word. Okay, so I would be having my sizes 5. Initially, all of them would be 0. Now, I'll traverse the words array, and for each element, I try to find if this particular string is satisfying our condition or not. ABA is satisfying our condition. For this particular element, I would add the previous element sum and this element key. If it is satisfying the condition, I would increment it by 1. So it doesn't have a previous element. In this case, I'll just increment it by 1. Okay. If I move to BCB, it is not satisfying the condition. So I would be returning 0, but the previous computation is 1. So 1 plus 0 will give us 1. Okay. If it is satisfying the condition, that in that case we are incrementing it by 1. I move to the next element, ETE. It is satisfying the condition. I would increment it by 1 plus the prefix sum of the previous element. Okay, prefix sum of previous element plus if it is satisfying the condition, plus 1 if satisfy the condition, if satisfy condition. It would be easy कि it is satisfying the condition. Okay, 1. And the prefix sum of previous element is I minus 1, 1. It would be 2. Easy. We move to the next. AA. It is satisfying the condition. We would be adding 1 plus the previous element is having 2. It would be 3. Now move to the next element. It is satisfying the condition. Yeah. I would add plus 1 plus the value present in the previous index. 3 plus 1 will give us 4. Okay. We now have calculated the prefix array. And now what we need to do, we just loop over the queries, and with the help of the pre-computed results, we can easily find out key what will be our output. So I'll write down the queries 0 comma 2, then we would be having 1 comma 4, then 1 comma 1. Okay, so for 0 comma 2, because it is inclusive, so I would be taking help of prefix sum of 2 minus prefix sum of 0 minus 1. Okay, so prefix sum of 2, 0, 1, 2, 3, 4. What it will give us? It will give us 2, and 0 minus 0 minus 1. So it is out of bound. So whenever the index is out of bound, I will replace it with 0. So it will give us output as 2. Okay. Again, prefix sum of 4 minus. So because it is inclusive now, so we don't need to include the given index. We need to maintain key for the previous index also, because we need to include this particular index. So for the previous index also, we need to do a minus 1. So for prefix sum of 4, it will give us 4 minus p of 0 will be 1, will give us 3. Prefix sum of 1 minus prefix sum of 1 minus 1. Prefix sum of 1 is 1, prefix sum of 0 is 1. It will give us 0. Now, if we try to analyze what we are doing actually, prefix sum of 2. Prefix sum of 2 means कि we are at this particular index and our range is 0 to 2. 0 to 2. Our value is 2. We know that. So for this particular index, we are having our value as 2. And why we are doing a minus 1 here is because we need to include that 0th element. We need to include it into our computation, so that if we are at 0, we know it is incremented by 1. If we are at 1, it is not satisfying the condition, it would be 0. If we are at 2, it is having our value as 2. In this case, if we know the pre-computed value till this particular point, we can easily find out without any pre-computing, any computation for the particular query. Okay, so for this approach, we require only traversal. If I write the algorithm, it would be easy for you all. If I write the algorithm, firstly, maintain a prefix array and traverse over words such that if word of I satisfy condition, make prefix of I minus 1 if I is greater than equals to 0, otherwise it will be replaced by 0. plus 1 if satisfy the condition. Otherwise, it will also be 0. Okay. And if we are traversing the words, let's suppose it would be take us order of m time. The second thing is, for all the queries, or what we can say, traverse queries array, and for a query of I, because we need to maintain a answer array na, for a query I, the answer of I would be such that prefix of query of 1 minus prefix of query of 0 minus 1, because we need a inclusive value. Okay, it would be easy, and the time complexity would be order of n for this case. The total overall time complexity would be order of m plus order of n. So the total time complexity is order of m plus n. That is far efficient than m into n. And the space complexity would be order of m, because we need to maintain a prefix array for a for our pre-computed values. Okay, so yeah, for each particular, what we can say, cases, we will code it out in Java so that it would be easy for you. So let's suppose what we need to do first, we need to maintain a prefix array that would be having a size of words. So int word length would be words dot length, because it is an array. So dot length would be a would give us the word length. We need to maintain a prefix array, prefix new, it would be a integer, and it would be having word length. Okay, now for each element in words, because we need to maintain the prefix array also, that's why I am using an index loop. Otherwise we can also use for each loop. So for each word in the word length, I'll check if satisfy the given word satisfy the condition, that is words of I satisfy the condition, then I would be having, I would be incrementing it by 1, otherwise it would be 0. So it would be a, what we can say, count, or what we can say, ki for this particular word vowel count, we can name it as anything, vowel count. Okay, if it is satisfying the condition. Otherwise what we can do, if it is satisfying the condition, we would be having the value as 1. If it is not, it is having the value as 0. And for every case, the prefix of I would be updated by prefix of I minus 1 plus vowel count for this particular word. But there might be a case for index 1, index 0, ki 0 minus 1 will give us minus 1 index. In this particular case, what we can do, we can apply a condition here, ki if I minus 1 is greater than equals to 0, then I need this all values to be updated. Otherwise, only the vowel count will be matter to us, because I only want the prefix value, or what we can say, the previous array element value, if the arrays if the index is greater than or equals to 0. Okay, I'll updated my prefix array. Okay, it would be updating correctly. Again, what we will do, we'll maintain this, we will make this boolean function in a while. After that, what we need to do, we will traverse the query array. Int I equals to 0, I less than, I'll maintain a variable for query length. It would be queries dot length, query length I plus plus. Okay, for each query it would be having a x value, or what we can say, we can be having a starting value of queries of I. It would be having a starting range and a ending range. Queries of I. Okay, and we will just be using our prefix array for updating our answer. So answer would be returned in an answer array equals to new int query length. Okay, so answer of I would be updated by prefix of ending minus prefix of starting. And if starting minus 1, if s minus 1 is smaller than 0, we'll check the condition. If s minus 1 is greater than or equals to 0, then only we need the prefix of I minus 1, otherwise we would be satisfied with 0. Okay, okay. uh i think I think it would be working fine. I'll just need to create the is satisfy condition, if satisfy condition, and I will return my answer. So I have implemented the particular algorithm. I just need to make this function if satisfied, boolean if satisfied, string of word. And this will also be requiring us only a single step, कि I need to verify कि if the first word, that is if vowel, if ni is, it would be is vowel of word dot char at 0, the first index. And it would be the condition कि if the string is existing in the words array, it would be having its size minimum as 1. And is vowel, the last index, word dot char at word dot length minus 1. Okay, and I would be returning it from here. I would make this is vowel function, in which I would be using a switch case statement. Boolean is vowel, it would be a single character, and boolean is vowel is equals to, initially it would be true, and I would be accepting the switch case in which I would be passing this particular character, and I would be having my case as A E I O U, A E I O U as my case, and that in that case I will break it. Otherwise, if it is not satisfying this condition, the default would be vowel equals to false. Okay, and I'll return the vowel variable. So it's just purely simple key. I would traversing the words array. I'll maintaining my prefix. Using the prefix, I'll query out the element, and this would be doing my part. And if we try to run it, and if we have not made any syntax error, it would run fine. And if we try to submit it, it will be submitting fine. If our code is correct. Yeah, our code is correct. So, so this was the solution to the problem. Count vowel string and ranges. I would be attaching the PDF of this particular solution. I'll be writing pasting this particular code in the PDF as well, so that it would help you. Okay. So for more further videos, you can subscribe to the channel, and if in case of any query, you can comment it out. Okay. Bye bye.